Hello and welcome to lesson 3.5. This lesson is titled Big Mac Exchange Rates, and we're going to be learning about direct variation and proportions. It can be found on page 343 of your textbook. I like to actually introduce this as the very first of our line equations. We're going to have three different equations of a line, and today is the first one. So 3.5, dealing with direct variation, will get us into the other ones. Towards the middle of the page, where it says 3.5 class, it describes what an exchange rate is. An exchange rate is a number that describes how much of one currency you can trade for another currency. For example, if the US exchange rate in Canadian currency is 1.35, that means you could trade $1 US for $1.35 Canadian. When travelers talk about how expensive or cheap a certain city is, or country is, it's often a reflection of the exchange rate. They were talking about Big Macs earlier. The average cost in the US in July of 2022 was $5.15 for a Big Mac. In India, it was just $2.39, and in Norway, it was $6.26. Number one introduces us to one type of exchange rate. As of October of 2022, the exchange rate for Indian rupees was $1 equals 82.1 rupees. Write this rate as a conversion factor with US dollars in the denominator. This is very similar to what we did when we did dimensional analysis. We wrote it as a fraction, and they are telling me here they want the conversion factor with US dollars in the denominator. So I'm going to put the $1 in the denominator and the 82.1 rupees on top. What this will now allow us to do is to convert from dollars to rupees. Just as a real quick refresher to how we did that when we did dimensional analysis, we set up what we called train tracks. This one won't take too many, so I can keep it fairly small. And I started with 0 US dollars in this case. And if I put my conversion factor into the next track, I have dollars on the bottom, which is good. That means they'll cancel out. And 82.1 rupees on top. And just to refresh your memory, when we did this with dimensional analysis, we said, oh, look, the dollars cancel out. I'm left with rupees, which is what I wanted to get. This first one's relatively easy. What is 0 times anything? 0. We'll do one more train track, and then we can show you, you can just replace the number each time. The next conversion wants me to convert $10 of US dollars. So I'm going to start with $10 here. Put my conversion factor with the $1 on the bottom and 82.1 rupees on top. I don't know if there's a shorthand way of writing that, so I'll just leave it. I have an extra decimal in there I need to get rid of. So again, we show that the dollars cancel. I'm left with the label I wanted, and then all that's left is to do the arithmetic. So I'm going to have to do 10 times 82.1, and I'll get out my handy dandy calculator, and we'll type in, as soon as it turns on, 10 times 82.1. And it's difficult sometimes. That may have been user error that time, 82.1. And the calculator tells us that the answer is 821. Do the same thing, but this time do 20 instead of 10. So 20 times 82.1. And I get 1,642. Continue doing that to finish filling in the chart. You'll find that for 30, you get 2,463. For 40, you get 3,284. And for 50, you get 4,105. So now that we've completed our table, let's graph those points. So we're graphing using the table at the bottom of page 343. We're going to graph at the top of page 344. So I'm going to keep my table open here, grab a darker color, and I'm going to make it a little thicker so my lines are a little easier to do. My circles. That's probably too big. That's a good size point. And we can go a little bigger. Yeah, that'll be a good one. So we need some labels first. I just realized they didn't give us any labels. So I'm gonna use the text to do that and actually type it in. So we're gonna use dollars across the bottom and rupees, R-U-P-E-E-S, it's not typing. The Indian, I just spelled that wrong. The Indian money. We'll use that along the side. And then the author recommends going up by 5s across the bottom. So he actually writes in, not all of them. He starts with 10 here, 15, 20. And let's go back a little bit. It's hard to read. 25, 30. Skip 35 and go to 40. So he's going by 5s. He's just only writing every other one in. And then along the vertical axis, his recommendation is to go from 0 to 4,500 with 4,500 at the top. And then each line he's counting is 250, but again, he's not writing them all in. He does every other one. So this would be 4,000. I have too many zeros up in that first one. And then 3,500. 3,000. 2,500. They're not quite evenly spaced here. 2,000. 1,500. 1,000. 500, and then we'd obviously have 0, 0 at the corner. I'll go ahead and put the 0 in here as well. All right. You may question, why did we choose those? Why are those the values we chose? We chose those values because I knew my dollars had to get up to 50 because that's what the table did. I knew my rupees had to get up to 4,105, so we went a little bit above that. So we're trying to make sure we get enough in so that we can see it. All right, we know $0 was 0 Indian rupees, so I'm going to put a point at 0, 0. I know that 10 US dollars was 821, so this would be 750. It's a little bit above that. 20 was 1,642. I just realized I put that in the wrong spot. That was 10. Helps if I can read my own label. And then 821. 20 and 1,642, which is just a little bit above 1,500. 30 was 2,463, which is almost to 2,500. 40 is 3,284. And this would be 3,250, so we're a little bit above that. Pretty close to that though. And 50 is 4,105, so it is about halfway between those two. So if you notice, they do form a straight line. Again, we kind of talked about that everything we're doing in chapter 3 at this point will be linear. And we can even go ahead and connect those with a thinner line. With an arrow going off to the right because it goes on forever that way. So it's definitely a linear function, definitely a line again. They asked me to find the slope. So to find the slope, I need to find 2 of the ordered pairs. I'm going to look back at my table to do that. I like the smallest two because they're easy to work with. It doesn't matter which two you pick. I'm going to pick 0, 0. And then from that table on the previous page, I also had that 10 was 821. If you remember, we did slope in section 3.1. We learned that to find the slope, we subtract the y values. So we're going to take 821 minus 0, which gives us 821. And then in the same order, I subtract my x values, 10 minus 0, which is 10. And then we get out our calculator, divide it out, and we get 82.1, which should look familiar to you. And they're asking me, what does that represent? Well, if you look back where we started, they told me that $1 US was equal to 82.1 rupees. That's the same number we just found finding the slope. So that slope is the number of rupees that correspond to $1. So rupees per dollar. And that is something I love about this course, is that we are finding the meaning of numbers now. It's not just enough to say, hey, I got the number. We want to find out what they mean. So we want to write an equation now. I want to use x and y. Y is the number of rupees that we can trade x dollars for. So we're going to write y equals, what did I do in that table each time? I took the number of US dollars and multiplied by 82.1. So that's our equation. Y equals 82.1 times x. They ask you for the input and the output. The input is the US dollars. That's the part we're putting in. So we'll say input. The output is however many rupees it comes out to be. So that's the output. If you think of an equation as a machine, you put the x in, something happens inside here, and a y comes out. What's happening inside this one is that it's being multiplied by 82.1. Now they want us to use our equation to find the current cost of a Big Mac if it's $2.39 in American dollars. So I'm going to use this equation, and I'm going to replace x with $2.39. And that will tell us the value in rupees. So I'm going to do 82.1 times $2.39. And that tells me the cost for a Big Mac is going to be 196.219. Since I'm in money, I'm going to round that to 22. And that is in our rupees. I love number 7 because it gets us to practice on the graphing calculator a little bit. It says use your graphing calculator to verify the table and the graph. So this is awesome. We get to pull the graphing calculator out. And all of your graphing buttons are right below the screen. Y equals lets you enter an equation. Window lets you adjust the window. Zoom zooms in and out. We won't use trace much. Graph actually graphs it for you. The things above it help too. Stat plot will be statistics graphing. Table set is how we create a table so it matches the one we had on the previous page. We probably won't do much formatting in here. Calculate would let you calculate some answers, and then tables where you get to see the table. So we want to start with y equals, and we want to clear out anything you may have in there. If you have anything in there, just type clear and then enter, and it'll clear out the equation. And we're going to type our equation into that, 82.1. To get the x, it is a button that says x, comma, t, comma, theta, comma, n. It's right next to the green alpha button. I'm going to push that button and it shows up an x. So that's how we enter the equation. Now let's set up our table. So I want to do table set, which was in blue. That means I have to use my second function. So second window will let me set up my table. Once I click that, it should say table setup at the top. My table on page 343 started at 0, so that's good. I'm going to hit enter there. But it didn't go up by ones. It went 0, 10, 20, 30, 40, 50, 60. That's going up by tens. So I'm going to change that. Now I'm going to hit second graph because that's how I get the table to show up. And there's the same table we got. They did it all for us. It matches our table exactly from number 1 or 2. I can't remember. It's on page 343. All right, let's make our calculator graph it too. Before I actually push the graph button, because I don't know what kind of window I have set in here, I'm going to push the window button. I want that to match what we had on the top of page 344 in number 3. My x's went from 0 to technically 55 because it did go 1 past. My y's went from 0 all the way up to 4,500. I did forget to change my scale. I forgot my scale. The x scale was going up by 5s. My y's went from 0. Touch screens are sometimes frustrating. 0 to 4,500. What did our y values go up by? Looks like we went up by 250 each time. So all I'm doing in the window is making it look like the window we had in number 3 after we set up our scale. Push the graph button and you'll see a really nice picture of what our line looks like. So we verified on the calculator. Number 8 says, how many rupees do you think you would get if you gave them $0? Well, if I give them $0, I better get 0 rupees. On the next page, page 345, they ask us, if you doubled the number of dollars, what do you think happens to the number of rupees? Let's go back and look at that table we had, way back here. Doubling. If I went from $10 to $20, that doubles. 20 is twice 10. How do the rupees compare? How does 1,642 compare to 821? Take a guess. If you said doubled, you're right. 2 times 821 is 1,642. So our answer for that one, number 9, is if I double the amount of dollars, I'm going to double the number of rupees. What do you think happens if you triple it? Triple means times 3. So in the table, go back and look at when I went from 10 to 30. 10 times 3 is 30. What do you think we did to the 821 to get 2,463? If you said tripled it, you're right. So whatever we do to the dollars, we have to do to the other value as well. So it also triples. What about if we cut the dollars in half? All right, so let's go look at an example in the table again. When I went from 20 to 10, 10 is half of 20. How does 821 compare to 1,642? You catching on? It's half. So basically, whatever we do to the dollars, we do to the other value. So they put this together about the middle of the page on page 345. Here are some conclusions we can draw about exchange rates. $0 give you 0 rupees. If the amount of dollars goes up, the amount of rupees goes up by the same factor. If the amount of dollars goes down, the number of rupees goes down by the same factor. That's where the half, tripling, doubling comes in. What we are talking about here, what we have been talking about this whole time, but not exactly named, is that this is direct variation. These quantities vary directly, they're directly proportional, and they are direct variation. And then they give us what the form of that equation is. Y equals K times X. It's a very special type of form. And at the very bottom of this page, they give us exactly what this form tells us. So this is what they've just told us. Algebraically, direct variation looks like Y equals K times X. What's different here from what you'll see in the next sections is there's no plus a number or minus a number. If it's Y equals KX, Y equals 3X is an example of direct variation. Verbally, we say the quantity Y varies directly as the quantity X, and the constant of variation is K. Numerically, we have a table very much like what we saw here. Graphically, this is my favorite part. Direct variation in a graph is a straight line. That's condition number 1. Condition number 2 is it has to go through 0, 0. It has to go through the origin to be direct variation. So again, this is the first equation of a line we're dealing with. We're talking about y equals kx. And it might even be helpful as we get into the next sections after this to think of that as y equals mx. And you'll see more of that in the next section as to why, but k is the same as your slope. So that's the end of the first section of equations of lines. This one is direct variation, and you will get some more in the next couple sections. Thank you, and I hope you have a wonderful day.